Action.
Right now, things with this storm coming in the next couple of days, temperatures are gonna drop into the 30s. Stuff's gonna start slowing way down. You'll kind of think your roses might be in suspended animation, which isn't always a bad thing. You get nice color and they last really well as cut flowers. So, and as far as stuff to do in the garden right now, you can do another fertilizing with like the Magnum Grow or a water soluble if you want to. Organics probably aren't going to do you much good this late in the season, although they continue to work throughout the winter. They're just slower to react, but anything water soluble could be used probably one more time. Watering right now, I would say probably half the frequency that you were doing in the summer, maybe even a third. It's still the same volume, but much less frequently. The plants are not transpiring water at any kind of rate like it was in the, I mean, June's just unbelievable how much they can put out in a very short period of time. But, you know, the humidities have been running between 30 and 45%, and with the cooler temperatures, you don't need to be watering there as much.
And how much water are we talking per rose?
I think a decent watering on a rose in the ground is probably 4 to 5 gallons, if not more. If you have drippers, they do not want to be by the trunk. You want at least 2 per plant, and they should be 12 to 15 inches away from the trunk. 3 is even better if you can triangulate them. And now it's a good time. Well, it's hard to do right now. You probably have to wait until you do your pruning in January. Once you get all the leaves and stuff cleaned up and everything pruned back, you can turn your system on and see which drippers are working, which ones aren't. While they're running, you can pull the emitters off the tubing and make sure that they're working right. Just remember when you pull that off, you're not looking at it. Yeah, that nice cold water in the middle of January will keep you awake anyway. But it's a good idea at least once a year to go through your drip system while it's running and take the drippers off and make sure that they're actually working. If you have too many drippers on your lines, even if they say a gallon per hour, you can take a 1 gallon milk jug, put your dripper in there and see how long it takes it to fill up, or see how full it is after an hour. You're probably going to find out you're not getting anywhere near a gallon out of them. If you've got a lot of them on one line, and if you have all your pressure coming from one end, the ones on the far end are not going to be getting near as much water. It loses volume as it goes along. So, if you're planning on ordering new roses, I would do it as soon as possible. Trying to get stuff is hard. You're going to run into the same problem with everybody else with groceries and everything else with supply chain issues, deliveries, transportation.
And running out of stock quick.
And running out of stock. You know, a number of companies have gone out of business. Some of them have cut back on the quantity of roses that they produce. So get your name on the list early and tell them you want them in January or even sooner. For some reason, they like to send them they think Arizona's all Phoenix and it's hot, or they think it doesn't matter and they can send them in March and April, and it doesn't work at all. So I had a nursery in Green Valley, and I guess the people down there would order them, and people thought that Green Valley must be up in the mountains somewhere, so they didn't send them till March and April. And people would come into the nursery with their roses in March and April, and I said, well, good luck, you know, just do the best you can, and I give them some advice on things of what to do, but tell them you want them as soon as they're available.
Reagan Nursery is, their plants are available right now this month. That's a pretty reliable bare root company, but you wanna order them now before they sell out of everything. And then when you, in the ordering process, specify that you want them as early shipped as possible, like early February is probably as early as you're gonna get them. Also, K&M Nursery has a bunch of stock going on now, so if you want Fortuniana roses, you wanna get some from K&M, and the best way to do it is just to either email him or just call him on the phone, call James. But he's got pretty good stock right now.
Yeah, but once everybody gets their heart started, they go really quickly. And especially if a variety's gotten a lot of publicity or something for some reason, and it's a really good one, it'll all disappear in almost no time at all. So. Anybody got any questions?
Come on, don't let him off the hook like that.
Okay.
Oh,
What's your true feelings about drip systems?
I'm not a fan of them. Most of them are poorly installed, poorly maintained, and poorly operated. I've seen drip systems where one line runs all the way around the yard, and it doesn't matter whether it's rose bushes or mesquite trees. So it's about 95% of what's on that line is going to get miswatered. Mesquite trees should never be on a drip system anyway.
Do you use a shrub type bubbler thing?
Yeah, I used to use just plain old bubblers when I had it in the ground, hard pipe, 3/4 inch PVC pipe with a thing that sticks up in a little adjustable bubbler, and would flood the area underneath the roses. And then when I went to all pots, I put what they call shrub sprayers, and I'd have a drip line going up there, and the shrub sprayers that are adjustable, and they have about 15 little sprays that come out, and you can adjust it just to fit the size of your pot.
Like a little umbrella?
There's a couple of different kinds. There's some that are sort of umbrella. The ones I had were pretty much flat. And you could adjust them.
hey Jerry, Sarah.
I didn't have any pressure
He gets
regulator
right in the
on
middle of
mine,
it.
so occasionally I'd have a shooter, but that worked very, very well.
Yes, they'll be your breakfast.
You know, it hits it, and it helps carry fertilizer down and stuff
Well,
like that.
it'll be mostly crazy, you know,
The
bagel.
drip system's in the ground,
Fruit.
they get plugged up, if you've got rabbits in the area or rock
Thanks.
squirrels, they'll chew through the lines. And most people put way too many drippers on a line. Again, when you start running it out, the ones that are getting a gallon here are getting a half a gallon at the far end. And they do have what they call a loop system, where you come in and you split the pressure. You split the line, and it makes like a big loop. And that evens the pressure out a lot better. But, yeah, just, so many of them are just really poorly put in.
So you're never gonna get away from the hose.
No, if you don't own a hose, you can't grow good. If you don't own a hose, you can't grow good roses.
Oh.
Yeah.
Jerry Mahoney says hi, by the way.
Check it on you.
Yeah.
All right, when did they? Yes, sir. Did you?
No, I was just.
Oh, all right.
Like an auction, that's dangerous.
You just spent $100,000 and you didn't know.
That's a lot of bushes.
Yeah. Well, the price of stuff, it won't be very many bushes very long.
No.
I ordered some Magnum Grove in 25-pound a couple of weeks ago, and a year ago I was selling for $25, and now it's $40. Suggested retail is $58.
Oh.
Yeah.
I think all fertilizer has gone through the roof because so much of it comes from Russia and Ukraine, which I didn't know about.
Right.
And now there's a big shortage.
And it's all, a lot of it's petroleum product.
Well, a lot of it's mined too. A lot
Right.
of,
Yeah, the phosphate and the potassium. Phosphate is hard to come by these days.
Yeah, it's, everything I bought in the last year has been double what it was 3 years, or more, what it was 3 years ago, pretty much. So, and I wouldn't be surprised to see major price increases right after the first of the year. So as I said a couple of times before, if you have a fertilizer you like and you see it at a price you can live with, you know, you got a place to keep it dry, keep your powder dry, you can, you might want to stock up on it.
And if you can drill your own well, that'd be handy.
All right.
Okay. Thank you. I'd like to introduce the speaker.
Turn on. Okay, we're really, really lucky to have Dr. Tim Anderson come over from Phoenix. He's one of the world's leading authorities on climate change. And he's been doing this his whole life, and he's been to exotic places like China, Tasmania, and you name it. I mean, he's been all over the world studying and working with different people. But basically, to give you an idea, here's just, while he's technically retired, he still does a lot of running around, but he's a professor emeritus at Arizona State University Engineering Department and specializes in atmospheric chemistry, cloud chemistry, microphysics, aerosols, air quality, atmospheric processes, scientific basis of climate change and climate action. He knows what he's talking about. He's really good. Plus, he's not only that, he's one of the best rose growers in the entire state and an elite arranger too. If you've seen his show, go to rose shows in Phoenix, and if we're lucky here in Tucson, we get them, but not all that much.
It's hard to get him down here for our show.
Well, I hope to go in the spring, we'll see.
But he is elite. I mean, it's, when you see one of his arrangements, you just, something to die for. But anyway, here's Jim, and he's going to explain everything about climate change.
Yay.
So are you recording or does it matter?
I'll record your PowerPoint.
Okay, that's fine. So, anyway, my work's taken me around, but I've also done work in Arizona, a lot of work along the border. I work with brick makers in Sonora, with big local pollution source. And the most recent and still current project on the copper smelter at Hayden, which is probably the most toxic air in the state of Arizona because there's so much fine particulate lead. Anyway, so, but I want to talk about climate change, local climate change, global change, some of it that's natural and some of it's man-made. So let's see if the clicker works. It works. So, let me get my here, there we go. So these are some of the things that I've spent a lot of time in that C-130, maybe 800 hours flying around the world in the science crew, out of Japan, out of the Maldives and the Indian Ocean, out of northern Chile, out of Tasmania, different places. Anyway, and that gives you a different insight into the world. I've also sampled off of this ship, the NOAA ship, the Ron Brown, but I never go on it. I always get somebody else to go and run my equipment because I don't want to be stuck on a ship for 2 months. So, and that's another. So NCAR is the National Center for Atmospheric Research. I'm still involved in the governance of NCAR through the University Corporation for Atmospheric Research. Anyway, this is the G5. This takes a small science crew, only maximum of 15 people. This will take like 30 people, so you can put a lot bigger payload on that. But this thing will get you a lot further. I mean, we went back and forth between Colorado, Anchorage, Japan, Honolulu, Colorado. We were doing these legs like that, doing sampling. The middle of the Pacific going like 200 feet above the ocean, which is scary because there's no radio contact or anything if you ditch you've had it, so. Anyway, we plan on not doing that. So anyway, what I want to talk about, and make sure I don't go too long here, are some local trends and then regional trends and stuff about the drought. So start with temperature trends in Pima County, and also in the, I've got some data from Phoenix, and there's more data in Phoenix than there is in Tucson because people collect more data there for whatever reason. But the drought in the southwest and some effects on the Tucson area. And then about El Nino, La Nina, that cycle, which is a natural cycle. And then the climate change caused by human activity. So some of these are going to be, if you have questions, you might as well just ask them as we go along. Now, if I'm going to talk about it later, then I'll defer to later. But I want to make sure people understand, what I do. But anyway, the point of this graph, and I always give a source here. This is from NASA. So this is an index telling basically the global temperature, but it's down at sea level, it's on the land, and it's also over the oceans. Now the oceans, because of evaporation and other issues, are not warming up as much as the land. So the total warming globally is not as much as we might, experience here in Arizona. But anyway, the anomaly from the comparison is the average between 1951 and 1980. It seemed to be a period of relative stability. It's in here. Any data before, from the end of World War II and before, it's not so reliable. There wasn't much data, and certainly during the war years, people weren't worried about temperature data. So anyway, but anyway, since 1980, there's been this steady climb. This is this index, and from the index, the global change is about 1.5 degrees Fahrenheit, which doesn't seem like a lot, but it's a lot of heat. So, and then it turns out that most of the heat goes into the ocean, not into the air. 90% of the excess heat has gone into the ocean, only 1% into the air. But anyway, there's this trend, it's clear. I haven't seen any papers challenging this idea, and some of the other stuff I'll talk about in the past 25 years, challenging in peer-reviewed scientific papers. There are political tracks that they can make up whatever they want, so. So this is, I can't find anything quite like this for Tucson. This is a site called Climate Stations, and they didn't include Tucson in their list, but it is Phoenix. So this is 1895 to, around 1980. And again, the reliability of this data is, and this is data from the airport. Now the airport's got some problems because it's got all this concrete and stuff. But anyway, there's this clear rise from 1980 on, and this is the annual mean temperature. So it's a rise of, in this case, I don't know, maybe 4 or 5 degrees. Now, some of that might be the location at the airport. The National Weather Service has its main station at the airport. It's the same here. There's one at the airport. The airport here doesn't have the problems that the one in Phoenix has. It matters where you take the measurements. Anyway, so here's some data from Phoenix. This is from Tucson. This is from the NOAA site. All I could find on Tucson were these big, huge tables of data, and this is bad enough for people to look at in the audience, but the key is this column here. So there's the number of degrees, over 100 plus degrees in Tucson per year, and these are rolling 30-year periods, so 51 to 80, 61 to 90, 71, and so on, and the last period is 91 to 2020. So we start with an average over those first 30 years of 40 days of 100 plus. And again, it matters where you take it, but I think this is at the airport. So it's 40, and then as you go along, you get up to like 68 days per year of 100 plus. So this is a huge change in the number of 100-degree plus days just over this. For me, you know, it's well within my lifetime. For some of you that are younger, it's not, but anyway, so there's this clear trend, and the key here is this steady trend of more and more extreme weather. And if we look at the colder days, and again, it really matters where you take these measurements. But anyway, so it is the same rolling 30-year periods, the number of days of 32 degrees or colder, and you can see that it's decreasing. Now, if you live up higher, you may, you know, your experience may be somewhat different, but at this station where this is taken, it's clear. So there's more hot days over 100, and there's fewer cold days below freezing. So those are, you know, regular trends, and they fit with data in Phoenix, certainly. Okay, so and we'll look at some temperature data a little later. But, you know, let's talk about the drought. So this is there's a site, a federal site called drought.gov, and they consolidate data from different federal agencies. So there's the yellow area is abnormally dry, and this sort of light orange is moderate drought, and then this orange place, which has got, you know, Tucson and Agua Prieta, is listed as severe drought. Does it matter? Well, it matters for the wildlife, it matters for the native vegetation, certainly it matters for the forests up in the mountains, heightened fire hazards. And you've got animals that are stressed, don't have access to water or food that they normally would have, and they tend to come down into the cities. Yes, go ahead.
What is the standard to compare to for like abnormally dry versus moderate? I mean, we live in the desert, and the standard is to have.
Yeah, so you've got an average, long-term average of precipitation. And so someone has decided that this much below the average is abnormally dry. So you can look it up. I don't know the numbers off my top of my head, but there are long-term averages of what the precipitation normally is. Now, if you look at the Colorado River and the allocation of the water, that allocation was, the average used for that was done at a time of abnormal wet period. And so it's over-allocated. The Colorado River water is over-allocated because it was, the politicians drew up the compact at the time when there was wet conditions. So no matter what we do in terms of drought, the Colorado River is over-allocated in terms of, like the Central Arizona project. Anyway, these are, you know, you could look these, they're defined. You can go onto these sites and you can find it. I don't have it off the top of my head. There are two more categories after this, but anyway, Arizona it's abnormally dry, but it's not in severe drought. This is from a couple days ago, October 27th, and this is University of Nebraska Lincoln. They have a lab. Again, they consolidate data from different sources, NOAA, and it's mostly from NOAA. So the extreme drought, so there's, after severe, there's extreme, and then there's exceptional. I mean, you come up with these, and there are definitions. If you went and looked, you could find them. The severe, the extreme and the exceptional drought are in this area. So here's Utah and Nevada, and then in the Rocky Mountains here in Colorado, it's severe drought. Those are the watersheds that feed the Colorado River. And this is a long-term problem. It's been like 22 years of these kinds of conditions. So that's why the reservoirs, Lake Mead and Lake Powell, are rapidly dropping. And if you're in California, this is really bad news, the Sierra Nevada. The snowpack in the Sierra Nevada is the main source of stored water, staying as snowpack. And there's two problems. One, they're getting less snowpack, and two, it's melting earlier than normal. They don't have reservoir capacity to store the runoff. And the timing normally was that the runoff would occur when they were going to water the agricultural fields. And now, anyway, it's melting early, so they don't have the storage capacity, and then they wind up having to release water that they would rather store. So it's a double whammy. And there are other drought areas, but anyway, we're in a long term, and in the key areas, rather severe drought. And so our water supply in the west is problematic. I mean, even up in, Montana and Idaho, there's some issues, although they've been seen. Yeah, go ahead. You can speak. If I don't see your hand, just speak up.
It's interesting looking at the river map, because I know the Platte River in Nebraska is super dry, and I'm looking at everything's feeding into the Mississippi, which is
Right.
also
Right,
really
yeah, so
low.
the Mississippi is the driest it's been in memory, I think. And yeah, if you look at all these, so you got the Missouri and the Platte and so on feeding into the Mississippi. All these things, this whole area is under drought, and so the Mississippi is not getting the water, and
There's no water.
There's no water. And so the grain barges and things can't make it down to New Orleans, where they normally would go. So you've got all this Midwest grain stuck in, because they can't go on the barges. So yeah, no, it's a national thing, and the Mississippi is a really serious problem. The other problem in New Orleans is saltwater encroachment up the Mississippi. So where they would take, the water supply is now the saltwater is starting to encroach in because of the low freshwater level.
That's happening in the Yangtze River too.
Yeah.
The seawater is going up the river, and that's where Shanghai gets their water, is from the Yangtze.
Yeah, no, yeah. So anyway, we could talk about it. Anyway, so we got a severe drought. So now the one good thing for Tucson, and Phoenix has done this too, are these groundwater recharge districts. So if I can find, so Alverdon is there, and like Speedway is there. So right, and that's the center. This is, so the green is how much the water table has come up from putting excess Central Arizona Project water in, plus catching runoff from storms and, treated wastewater. And so there's been a big recovery in this central area where Tucson is, and you can draw on that for a while. I don't know what the projections are, depending on how much comes from the Central Arizona Project of Colorado River water. But anyway, it's certainly a buffer against some period of future drought. And there's a couple more. These are also these the groundwater recharge districts. And then at the bottom of the Avra Valley is another one. So there's been this water stored. Now there are subdivisions north and to the southeast which are not included in that, and they're pumping groundwater and dropping, so that the orange color is a dropping of the water table. The green and blue and purple are a raising of the water table. And so these subdivisions are rapidly dropping the water table, and their wells are going to have to get deeper and deeper and deeper, and eventually it's going to be lights out. And then they're going to be screaming for your water, so
Well, some of those people are already on Tucson Water, and Tucson Water has, their prices are higher than the regular city of Tucson Water
okay.
people. So that's how they're balancing out the delivery to those people.
So if you're unincorporated, Pima County, then you get a higher rate.
Right, well, and there's, but it's, I mean, that's an issue, and we already have one smaller subdivision in Phoenix, it's completely out of water. So, I mean, they were having water, their wells went dry, they were having water hauled in, now Scottsdale won't sell water to the water haulers, and it's like, anyway. So, and this, the Central Arizona Project Canal is like here. But these recharge districts, which were set up, I think, the late 90s and started in like 2000. So this is 2000 to 2018 is the most recent data that I have. This is from the Tucson city government. Anyway, it was wise to do this, and you have some buffer. But if the Central Arizona Project water continues to be a problem, then you know this won't last forever. Oops, what's going on? Okay, Colorado River system conditions. The droughts lasted more than 22 years. As far as anybody can tell, it's the, and again, this is a geological thing, but it's the driest it's been in at least 1,200 years. We weren't, well, there were people around 1,200 years ago, but they weren't writing down, you know, the water levels. So 2021 was the second lowest on record, and this was in May when I did this slide, but anyway, it's gotten worse. So, you know, there's the bathtub ring. Here, this is the Hoover Dam on Lake Mead, and this is one of the intake towers. It's much lower than this at this point, but at one point the level was here, and now it's, I don't know, it's like 50 feet below where this picture is. So, and you're getting to where you're getting below the lowest, you're getting near the lowest intake. So this has got a lot of busy stuff, but let's try to explain it. So, and this is from August 2021, but it serves our purposes. So the normal sort of high is 1,200 feet, but that would be just at the near the spillway level. So-called tier 0, which is when you start to worry, this is above sea level. So we're at the Hoover Dam on Lake Mead, looking at the level of the water. The tier 0 is 1,090 feet. So that's where you start to worry about. We are now under tier 1 conditions. Once it dropped past 1,075 feet, then tier 1 went into effect. And there's some, I'll talk about the reductions. So in May, the level was at 1,054. Well, what's called tier 2 kicks in at 1,050. So we were just 4 feet above tier 2. And then as of yesterday, we're at 1,046. So we're now well into tier 2, what's called tier 2A. And it keeps dropping. And so if it gets down below, that's 1,046. If it gets below 1,045, we're in the tier 2B, which means, but as we'll see, the operating plan is to operate under tier 2A, and I'll talk about it. So, okay. And so if you get below this, you're in a world of hurt. If you get into tier 3, you have to have major reductions. Everybody has to have major reductions. And part of the problem is that California has senior rights. So that we have to take major reductions before California has to take any. And there are negotiations that go on to try to get California to actually contribute. There is a level which is called dead pool. It sounds ominous. It means no water flows through the dam. No, so there's still water behind the dam, but none of it flows out. We're not even close to dead pool. So there's max pool and there's dead pool. And this is an old data, we're now well below 30% capacity of the Lake Mead. It's a big deal. And Lake Powell, of course, which is up here, is part of the system too. I'm not going to get into that, it just takes too much time. So anyway, this is the tier 2 reductions. So we went through tier 1 and we got to tier 2, and we were in tier 1 in 2022, and that required in Arizona excess uses like groundwater recharge zeroed out, no more. Agriculture was reduced by 65% in Arizona, which is a big deal. A lot of crops can't be grown, pecans, for instance, and a lot of things. There was no reduction in the municipal and industrial use, and the tribes which have senior rights over municipalities and agriculture had no reduction. So that was tier 1, and 2022 was tier 1 conditions. There was a press release from the Department of the Interior setting the operating conditions for 2023, and they have brought in what's called tier 2A. So this is just too many words, let's go through the highlights. So it's the first time they've reached tier 2A, and those conditions will exist between January 1st, 2023 and December 31st, 2023. If the standard reductions, which are written in the compact, are used, Arizona would receive a 21 total, the whole state, of their allocation, 21% reduction. It added 8%, and because California has senior rights, California would have no reduction. Now, Arizona, in part, gets to decide how to allocate this 21% reduction, and there's negotiations going on now. And you've heard there's some political stuff going on too. But anyway, there's some effort to get California to contribute to the reductions so that our reductions aren't 21. 21% is a lot of reduction in the Central Arizona Project water. So at that point, I mean, you can't zero out all the agriculture, so the cities are going to have to bear part of the brunt of it. Yes?
Why, who negotiated this? This is the craziest thing I've ever heard. Why don't they have it even across the board?
Okay, so it was negotiated in the early 50s. California had a strong congressional delegation. Arizona didn't. California, it was a political, California was more powerful. And so California got senior rights, and Arizona got junior rights, and Nevada too. And once these, water law is really arcane. Once these compacts are written, it's almost impossible to get them changed. You can do these negotiations for, one-time, help here and there, but nobody wants to change. California doesn't want to give up its senior rights. The tribes have senior rights too, but I think there's some justification there because a lot of water we take from their lands. Anyway, there's going to be reductions. We're going to operate at level 2A in 2023. I guarantee you that we'll be in level 2B in the next year. So we'll get to that level certainly by next summer. It's up in the air, and it's a question of negotiations and then deciding how you're going to allocate the cuts. But the groundwater recharge programs are done for now. Oh, my understanding, and somebody might correct me if I'm wrong, is that Tucson has normally been operating about 50% Central Arizona Project water, 50% groundwater. So if that stayed the same, your groundwater problem, it'll go lower, but it wouldn't be too fast. But if the cities get reductions, then it's gonna be a bigger problem. Okay. All right, so any questions on the drop? The drop doesn't look good. There's no end in sight.
I'm suddenly depressed.
Huh?
I'm just depressed.
And there's reason to be depressed, and we're gonna have to learn how to live with less water. In the days of people flooding yards, I mean, they do this in Phoenix, they just, you know, you open, and somebody goes and opens this big gate valve, and you flood huge areas of grass. I mean, you can't be doing that anymore. So I don't know if they do that, I don't think they do that down here, but they certainly still do it in Phoenix.
I have a question.
Yes.
When I'm driving on 8 from Tucson to California, we pass through like where the Colorado River is, and a lot of times we stay overnight there, and it had huge cantaloupe farms and
Right.
farming there.
Yep.
And all of a sudden, like you're kind of driving and what used to be a cantaloupe farm is all dried up. And they're selling the land water rights to
Right.
California.
Right.
It's like, do citizens get to decide that? Because it's hurting our state.
It is hurting our state. So the cantaloupe takes a lot of water, and we grow wonderful cantaloupe down in the Yuma area. It takes a lot of water, and these reductions are making it impossible to grow crops like cantaloupe. So I don't know, I mean, the rights, they can't sell the CAP, or the Central Arizona Project rights. I suppose they could sell the groundwater rights. It depends on what county you're in. The state law is really politicized. Some counties you can sell groundwater rights, and some you can't. Whether you can sell it to California, I don't know. But
And
it's-
when we ask, that's what they say.
Yeah, no, I believe you, and
understand how
it may well be true,
This could be-
because, you know, our laws in the state are not, they allow over pumping. We've got commercial operations out near Wilcox, for instance, which are dropping the groundwater table, you know, 500 feet, 1,000 feet. And ordinary people who used to have wells, they can't afford to drill a well, and then, you know, pretty soon those wells are gonna be even deeper, so, yes.
How is this affecting the Rose Farms? Do you
Well,
know?
I don't know, I mean, they're using Central Arizona Project water, so,
And they
it-
use
it-
flood irrigation.
and they use flood, it's got to affect them. I haven't talked to anybody about it, but I'm sure it affects them.
What did you say, the rose?
So we have the
Farms.
rose growers outside of Phoenix, out on the west side. And you have these huge, you know, farms that grow roses, and, I mean, and it doesn't matter whether it's in Arizona, even in California, they're not gonna have the water, so it's gonna be an issue, for rose production. Now, how many of those roses wind up at Home Depot, and how many wind up in, you know, I don't know.
I know you're specifically talking about drought concerning our area, but also there is a drought pretty much hitting a lot of different countries across
Yes,
the world. And I know in Alberta, I was just reading a whole thing about inflation and all that stuff happening in Canada and how they're coping with it. But they were interviewing farmers in Alberta, which is north of Montana. And they're saying they're having a severe drought.
right. Well,
And that's part of what
Right.
feeds into the Mississippi River.
so,
You know, Montana's in severe.
Yeah.
yeah, Montana, and, you know, this doesn't, obviously, oh, here it is, wait a minute. Anyway, it doesn't, I mean, all the weather ends at the border, of course. But anyway, now, I have to say one thing though, it's balanced. There is actually more evaporation of water in the oceans now because of the heating than there was before. And that means there has to be more rain. So for every area that has a drought, there's an area with excess rain. it balances. So you're flooding here, you got drought there. And so it depends on who lives there and anyway, but it's balanced. If it's colder here, it's warmer there. If it's wetter here, it's drier someplace else. So, anyway.
Didn't Pakistan have like horrible floods or Bangladesh?
Yeah, I know,
or something?
Pakistan had humongous floods. So, all right, so let's go to El Nino and La Nina. So there's a lot to put in here. Let's see here. That says on. Oh yeah, now it's working. I just had to turn it on. So right now we're in a condition that's called La Nina. The original condition was called El Nino. El Nino means the little boy, and it's a reference to the Christ child, and it's a sarcastic reference because the conditions, as we'll see, of El Nino caused the fishing to be bad off the coast of South America, off the west coast of South America. So the fishermen basically said, this is El Nino's Christmas present to us. We don't get any fish. So El Nino is an old name. La Nina is a new name. It's the opposite, as we'll see, from El Nino. There was a competition between El Viejo, the old man, and El Nino, the little girl, and La Nina. Anyway, the basics, and I'll show this again. During El Nino, we tend to have wet and cooler conditions, especially wetter conditions, in the southwest. And that's because there's a stationary low pressure system that sits and throws off storms every 3 to 5 days. They come roaring across, and it depends on the position of this low pressure system, up and down, north and south, as to how much we get. California might get the brunt, we might get a lot. And the other thing to notice is the jet stream. So this is the Pacific jet. So these are up at, 40,000 feet, whatever. And this is the polar jet. So these are steering winds, very strong winds. They steer the weather systems. During La Nina, where we are now, the Pacific jet is further north. There's a big high pressure system that sits off here in the Pacific. And we don't get this low pressure here that would normally produce storms. So this area of the US and Mexico is drier than normal. So, I mean, these are extremes. And the other thing is the polar jet does crazy things. And so these big incursions of Arctic air down into the US are a La Nina effect because of the polar jet is doing crazy things.
So we're not El Nino, we're La Nina this year.
We're in La Nina. We're in a triple dip La Nina. We're in the third year. There's some jokes on the internet on the climate guys. The Three Musketeers, they call it, or there's another joke about some kind of candy. But anyway, it's a triple dip of La Nina. That's very unusual. So we've had. Now this is a natural cycle. It's usually a 3 to 5 year cycle, and it usually goes between El Nino to neutral to La Nina to neutral to, so back and forth, El Nino, La Nina with neutral in between. Neutral just means sort of average. Okay. So why does it do that? So here's South America. Here's Peru. This is where the fishermen were mad because catch any fish, Australia, Asia, North America. The temperature of the surface water in this region of the Pacific along the equator is critical to El Nino and La Nina. And I'll try to explain why that happens. So when it's hotter than normal, so normally there's a current that comes here, Humboldt current, and cold water with a lot of nutrients comes up, there's upwelling, and it comes to the surface, and it feeds algae, and that feeds the fish. And so when this is cold, the fish are great, and the fishermen are happy. We did a project, we were in Arica, Chile, which is, I don't know about here, and then we were flying out over this. Anyway, and this is the Atacama Desert. The driest, you think Tucson, or, or Arizona Desert's dry. The average in Eureka was 0.1 inch per year water. A lot of people didn't have regular roofs, they just had slats. It didn't rain. So anyway, so if it's warm here, then the fish don't thrive, and we get El Nino conditions. If that warm water is shifted out here, we get La Nina conditions. So La Nina, it's colder than normal here, warmer than normal there. And El Nino, it's warmer than normal and then colder than normal. So it's a shift. And there's a chicken and egg. I'm not going to get into why, but there's a cycle, a natural cycle. So the key is when here's South America, here's the warm El Nino water. These are convective clouds. This is water evaporating, going up to the top of the troposphere, so like 45,000 feet, and turning into these big towering cumulus clouds. I got it like this. So this is the top of the troposphere. It'd be like 45,000 feet up. So this is along, near the equator. The band is called the Intertropical Convergence Zone. But anyway, that's not important. So El Nino, the convection is near South America and then over here near Africa. And these arrows are cold, dry air coming down. For La Nina, the convection is occurring here and then off in the Caribbean here. So that's the evaporation, and the cold air that's coming down is here. And this shift back and forth of where the evaporation is and where these clouds form change the position of these jet streams. So I don't know, I mean, that's a simplistic explanation. And the other thing to keep in mind is this isn't just water, it's energy. When you evaporate water, you release energy into the water vapor, and then it goes up, and then it condenses into either ice or water particles, and energy is given up. So it's an energy transfer from the surface up. Anyway, and it changes the position of the jet streams. And these are the things that you get. So again, the jet stream in El Nino is lower, the Pacific jet stream, and it's wet and somewhat cooler. And then you get warm conditions up here, Alaska and the Northwest. La Nina, which is now our third year in a row, we get warm and dry conditions, and we're going to get another winter of it, and I'll show you the forecast. And then this polar air, you get these huge incursions of Arctic air that comes down in and freezes Florida and stuff sometimes. All right, so this is the same basic cartoon. Drier, warmer, cooler, wetter. And that's the polar jet stream. All right, so seasonal outlooks. This is from NOAA, this website, and NCEP, and they do these predictions for 3 months. So this was done on released on October 20th, and it's valid for this November, December, and January. And this is for the seasonal temperature outlook. So there is a 50 to 60% chance, it's all on probability. They never do 100% because, then they can't say they're wrong. Anyway, it's done on probability. 50 to 50% chance of above average temperatures in Arizona, including Tucson. And then further out, the probabilities decrease, and then this is equal whether it's warmer or cooler. This is the seasonal precipitation outlook. Similar kind of prediction. The green area is above normal precipitation, and the brown is below normal. So if we look here, it's, it's a 50 to 60% chance of below normal precipitation for this corner, so Agua Prieta, but for the next tier up, it's 40 to 50%. So not super, but you know, there's even chance that we'll have drier than normal conditions for La Nina and warmer than normal conditions for La Nina. So anyway, you can go on these sites that they update these predictions, you know, as needed, and they give you some idea. And so if you're writing a farmer's almanac, you go look at this and write down, and then you pretend you know what you're doing. So anyway, climate change, so this is sort of the bigger picture. So the idea with the greenhouse gas warming is that it's kind of like a greenhouse. It's not exactly like a greenhouse, but it's kind of like a greenhouse. So you got a glass house, and you got sunlight, and the sunlight comes in, goes right through the glass. A little bit gets reflected, but most of it comes through. And it hits the surface of the ground, or the floor of the greenhouse, and it warms it up. So now, the floor is warm, or it's getting hotter, and the energy that's coming back is no longer visible like sunlight, but it's infrared. So it's like if you go to a hot, sidewalk and you put your hand down, you feel its heat coming. Well, it's infrared radiation. So that's the so-called, that's what's called here long wave radiation. It means infrared. It means the heat. So, well, the glass partially blocks the infrared rays from getting out. It traps it in the glass. Well, these greenhouse gases do the same thing, but they're not glass, obviously. They absorb some of the infrared, and then they re-emit it. Some of it goes back down to the surface, some of it goes back out to space, but they trap some of the heat. So the sunlight goes right through, but after it gets absorbed by the surface, or even absorbed by particles, like soot particles, dust particles in the atmosphere, then what's given off is heat. And that heat gets absorbed by, some of it by the greenhouse gases, and some of it goes out to space, and some of it gets sent back to the surface. Some of it warms up the air. So anyway, that's what's meant by the greenhouse effect. And you've witnessed this in your car, you leave your car out, and anybody who's got a black car in Arizona, anyway, so you leave your car out, the sunlight comes in, it gets absorbed by the upholstery and things, and it produces heat, and not all of it can get out. So it heats up, but it doesn't heat up forever. It reaches an equilibrium where there's so much heat produced that the amount of infrared going out is equal to the amount of excess solar radiation coming in. Anyway, it reaches an equilibrium. And that's what the atmosphere does. But anyway, so the main culprit is carbon dioxide. This is carbon dioxide. And this is data from whatever that is, 2006 or whatever. There's 2007 up to 2022, there's this steady rise. I mean, you can go different sites. I've been places where they're just actively doing this and they just plot it up. They keep updating the plot. We're burning fossil fuel. We're making concrete, which also produces carbon dioxide. And it just keeps increasing. And at some point, if we don't stop, we're going to get, anyway, there's lots of, I don't have time to cover all the effects. But the increase in CO2 is absolute certain, and it's the physics of its effect in terms of absorbing this long wave radiation, the infrared, is absolutely certain. It's just simple physics. Okay, so we can go back and look at ice cores in the Antarctic and in Greenland, little trapped air bubbles, and look at the CO2 in them, and you can see that it bounces up and down. So this is the this is the concentration of carbon dioxide, and this is time in thousands of years, 800,000 years ago. So we're bouncing up and down. little ice ages, there's different amounts of vegetation and so on. And then we hit the Industrial Revolution, and it goes boing like that. So this is 1950, and the current, well, actually it's higher than this, because this is an old graph. There's nothing in the geologic record that shows any kind of an increase like this ever before. And there's no reason why it should be. It's just the use of fossil fuel, coal and then oil and gas. So, in terms of their contribution, this is, I don't have time to explain all of this stuff, but this is how much effect it has on warming. This is called forcing. The gases make the atmosphere warm up or cool down. There's positive forcing means it makes it warm up. Negative forcing means it makes the atmosphere cool down. Anyway, this is all positive forcing. The red is the contribution of CO2, and it's getting worse and worse. Methane is the next one. Now, methane is not increasing as quickly as CO2, but methane is a very strong greenhouse gas, and it comes from, cattle, sheep, termites, rice production, landfills, oil and gas production, and so on. So, and then these are legacy refrigerants, that used to be in our air conditioning and stuff. They'll last for hundreds, if not thousands of years in the atmosphere. So they're not huge, but they're up here and they're there. So, and then nitrous oxide is, anyway. So this is methane change, it's increasing. This is the scale is a sort of a slip scale. It's focusing on the top part. Methane is increasing. And there's various reasons. So it's a serious issue. And one of the problems, so these are the sources, or agricultural source, any kind of fermentation, rotting, whatever, produces methane. Oil and gas is a major one, but this enteric fermentation, what does that mean? That means cows and sheep. It's the bacterial action in their stomachs turning cellulose into sugars, and methane is a byproduct. So, but that also includes termites, by the way. They do the same thing. And then coal mining, municipal solid waste is a significant, and wastewater. These are both significant sources. And rice cultivation, because you flood the fields, and there's decomposition under the water, and you make so on. So it's an issue. And one of the problems, for instance, with composting on a large scale is it produces methane, which is a strong greenhouse gas. So anyway, so this is and I don't know where this is an old slide. So, but anyway, it's not that old. I don't know why I didn't put the source in here. It's probably NOAA, but it could be another source. Average surface temperature, global average surface temperature, again, rising. This is in degrees centigrade, showing what I showed before. It's definitely increasing. These are the global trends. This is from NOAA. And you can see that the oceans are not warming in general as much as the land masses. The worst is here in Europe and the Arabian Peninsula and parts of North Africa. And then in the Arctic, which is a serious issue. So this is from satellite data. And then the ocean heat is a big issue. 90% of the extra heat is going in the oceans. That will have a permanent effect, not permanent, but a long-term effect on our weather, on the intensity of tropical storms, and even the weather patterns. I mean, some of the permanent, semi-permanent, it's not permanent, this long-term drought that we have, sort of semi-permanent shifts in climate, may be due to simply excess heat in the ocean surface water. But it's just speculation. All right, so ocean trends, and you've seen indirectly some of this in the news. You want some lobster? there's fewer lobsters. It's because the water off New England and the Maritimes is getting warmer, and the lobster don't survive. You want crab? The waters off of Alaska are getting warmer, and the baby crabs are getting meat. Apparently the cod can come in now because it's not as cold as it was, and they eat the baby crabs. So, I mean, there are places where it's warming. There are a few places where it's getting colder, but these places where it's really getting warm, changing the ecosystem. So the baby crabs don't live off here, the lobsters don't thrive off there. And in terms, this is sort of the last one, in terms of, these are models, what's it hold for the future? Depends on what we do. If we somehow, all of a sudden, get rid of fossil fuels, we can eventually, so this is the emission pattern. So this is the ideal. All of a sudden we stop emitting, burning fossil fuels, and we go back here. Well, the climate change effects still continue. It doesn't somehow reverse because the gas, the CO2 has such a long lifetime, and the heat in the ocean is hard to get rid of. If we do this kind of thing, we take longer, then we're going to get even bigger, temperature change. And if we just do business as usual, which is the red, it's just going to go off the charts. So the sooner we do it, the better. But we've already crossed permanent change. So, but the sooner we do it, the less worse it'll be. Anyway. So, Southwest is under persistent drought. There's no signs of lessening. We're going to have to adapt. The retention of heat in the ocean from the atmosphere is clearly documented. There are no papers published in the scientific literature in at least the last 25 years that seriously challenge that, and we need to reduce greenhouse gas emissions. But the climate change is occurring and will continue to occur. And it's just a question of how fast it'll occur, determined by what we do. So anyway, there's the late bean. Any more questions? I'm happy.
Thank you.
So the only thing really to do is to reduce these gases.
Yes, the only
No rain to build this up, there's no.
there are no engineering
Yeah.
solutions. I mean, you hear about, sequestering carbon dioxide, pulling it out of the atmosphere and doing something with it. Most of the plans are either too small a scale, it's just nonsense, or they create ticking time bomb. If you pump it into the ground, heat wells in the ground, it's a ticking time bomb. So, I mean, and then there's this discussion of putting aerosols up in the stratosphere, particles to reduce the amount of sunlight. Well, what does that do? That cuts the crop yield in China and India and Africa. So more people starve. I mean, these so-called geoengineering solutions in general are a lot of hooey. And the only real solution is to get off fossil fuels and to go to solar and wind. Yes?
So I have a friend who studies in the PhD program at U of A. One of his research is development of crops that require less water. That's
Yes.
part of his research.
Right.
And that's a part of the solution, right?
Well, it's part of the solution for the drought.
Yes.
So it's not a solution for the warming, the sort of climate
Right.
change issue. But for the drought, having, for instance, rice or wheat or whatever that uses less water, it's absolutely at least a near-term solution, partial solution. Producing, finding rice, developing rice varieties that don't need to be flooded all the time, makes less methane. That's helpful. I mean, there's all sorts of things. If you could come up with a cow that without less gas. I don't know that you can do that, but anyway, I mean, you know, those are important things. Now, I've, you know, been on thesis committees of grad students at ASU, working on methods to pull carbon dioxide out of the atmosphere. And they can do it, there are methods to do it, but it's too expensive and too small a scale. So, you know, but yeah, that kind of research is essential.
Is there a place in Iceland that's actually capturing CO2?
Well, there are places where they have these projects going, but if you figure out how much CO, you know, in terms of metric tons, how much CO2 is put on, these little projects are like,
Yeah.
you know, I don't want to belittle them, but
They won't make an impact.
they won't make an impact.
Can you do better fossil fuel? Is there, you know?
Well, coal is the worst because it's pure carbon. And so every carbon atom makes a CO2 atom. Petroleum, you know, oil is next worst. Natural gas is the least worst because it's CH4, so every molecule of methane makes one molecule of carbon dioxide and 2 molecules of water. But they're all bad. I mean, natural gas is better than coal by far. But the problem is that you have leaking wells throwing methane into the atmosphere, and that's worse than the carbon dioxide. So there's a lot of issues. We need solar
And hydrogen, is that an alternative?
hydrogen's an alternative. I mean, that's a way to store solar energy, for instance. Make electricity from solar energy, split water into hydrogen and oxygen, and use hydrogen fuel. You have to have the infrastructure, but yeah, that's a possibility.
So are they going to recommend that people stop eating cows? Would that slow it down?
Well, I mean, you know,
Don't take my hamburger away.
if we went, you know, I'm not gonna make, I mean, we have to make choices. The biggest effect is the carbon dioxide. The one sort of good thing about methane is its lifetime in the atmosphere is I don't know, 7 or 8, it depends on where it is, 7 or 8 years or something. It's just, carbon dioxide, you know, it's like hundreds of years, so, but, you know, cows are food things, so is sheep. You know, I can't say I don't eat beef, so. But the fuels are important.
The only problem with saying we're gonna go, you know, everybody should go to a plant-based diet is that it's very difficult when you're in a drought to try to grow enough
Yeah, right.
vegetables.
Well, and the other thing is in a wealthy country like the US, we can afford to be vegetarian, most of us, not all. In Africa or China or wherever, they can't. So, you know, I mean, in India they don't eat meat, but they eat, you know, dairy products as a major protein source. So, you know, you tell India, well, get rid of this major protein source. I mean, so in the wealthy countries, yeah, it's easy to say, oh, I'm going to be a vegan. But, you know, you can't be telling them, in areas where there's a deficit in calories and protein, you can't be telling people they can't eat.
Well, China eats a lot of fish, and now they're overfishing the whole global supply. They have these super fishing boats out there that, so they have to do what they have to do to feed their
but
people.
when the fisheries collapse, then they can't feed their people with the fish, so.
Yeah, it's not a win-win situation at all.
I mean, it's kind of like the water situation in those subdivisions near Tucson. You can keep pumping and pumping, but eventually it comes back to haunt you. And it's the same with overfishing. It eventually bites you in the backside because
It will collapse, the fish.
it'll collapse, yeah.
So now what's the good news?
What?
I said, so what's the good news?
The good news is we're a bunch of.
We're now, we
We're
grow
a
roads
bunch
all
of
right.
nice Rosarians. Or the good news in Arizona is we're getting more and more solar and we need even more, so.
Yes.
Thank you very much.
Thank you.